evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. It is Friday, July 24th, 2026. Welcome to the show. And as always, we have myself, we have our special guest at the bottom, Dr. Hughes with us. You're in Florida, correct?
Yes, correct.
Yeah.
Orlando, Florida.
And we have Philip. He's in the middle there. He's in Montreal, and I'm in just outside of Toronto. Lulu hopefully will show up maybe a little bit later in the show, and Bernie's running 20 minutes late, so we'll have to wait for him to show up. But anyways, it's been a very busy week. I'm getting ready to do my very first production build of my battery. My solid state battery technology, which I finally got the recipe finally done. Now it's going to go into production, and I got some interesting stuff lined up for that. The plan is we're going to get a system where we're going to have a refrigerator that is going to be powered by these cells. And basically, the fridge is going to be self powered. You don't have to plug anything into it, and it's self-sustaining, and it'll run the fridge pretty much indefinitely by itself. So we have in the works right now of a third party that actually manufactures uh, uh, refrigeration units, and if the cells go good, and yeah, it could spawn a very big contract as far as building these self-sustaining refrigeration units. So
Uh,
that's
I can put you in touch with some AI service that can in San Diego that can automate marketing and stuff like that, and you find partners and things like that. That's what I'm
yeah.
doing.
Just like right now, like as far as like the chemistry and the battery science, I've pretty much got that down. I've been really watching the battery industry, especially from China, CATL. They're probably the largest battery manufacturer on the planet, multi-billion-dollar company, and they're the only company out there that I've actually seen put out a real, quote unquote, solid state battery. Everybody else, there's always a thing where they'll have a liquid electrolyte, you know.
Yeah,
Um, so yeah, very interesting. So my cell is 100% solid state. There is
Wow.
no liquids at all. It's
that's
completely
very
dry.
convenient. That's very convenient.
Well, number one, when it comes to safety, before my batteries will blow up, they have to hit about 960 degrees. Okay, you take your regular lithium battery, they go critical bad at about 120 C. So magnesium, the flash point of magnesium is 960 degrees. So under pressure, high demand pressure, amperage, and all that, if I stay below 960 degrees, which I'm pretty sure I will, because my cells are actually showing some interesting, uh, they're not heating up like a regular battery would under a big load. So these things are not heating up. I actually dissect batteries and actually inspect the anodes for wear, dendrites, burning, all that kind of stuff. My cells aren't doing any of that. They're not burning up. So even under extreme load, like my cells right now, they're 4x4, and they're about 3 millimeters thick, and I can pull 10 amps out of this small tiny cell, and um, I can sustain 2.5 amps continuously. Now, where regular batteries, if you start pulling a load off a battery, what will happen is the voltage will start to go down, okay, but then the current starts diving off. It won't sustain the current. What mine will do, they'll go down, say a half a volt, but all of a sudden, what happens is my current starts to go up. And as soon as the current goes high enough, my voltage starts matching it. So instead of under a load where normally a battery would get pulled down, mine's actually accelerating up. It's going the opposite direction in current and voltage. So they're showing characteristics that are not normal for a regular battery to do. So, yeah, some really cool stuff happening with these cells. I'm trying to figure it out. There's a couple of universities, one in, I believe, Chicago's working on the magnesium cell, and also a university just west of where I live, about maybe an hour's drive, called
Yeah.
Waterloo University.
I can put you on the map very quickly. So let's talk. I'll
Yeah,
I'll put you in touch.
like here, just for an example, I'll show you the cell really fast. They're tiny, and when it comes to weight, like comparing to a regular battery, these things are like super light, like almost weightless. Not weightless, but let's see, take off my background here.
Well, with the anti-gravity, is going to be weightless.
So if you look at my cell, it's only about 3 or 4 millimeters wide. So
Wow.
actually, one cell itself is about 2 millimeters thick. So I've got three. Now, what's great about these cells, and very unique to these cells, as it's solid state, there's no liquid electrolyte. I can charge them in 10 seconds. I do a high voltage charge on it. These cells are fully charged within 10 seconds, and they'll run for over a week.
Wow.
So, yeah, here, actually, I'll do a quick charge test for you, just to kind of show what I'm talking about here. So what I do is I zap it with high voltage. So I got about 50 volts in this battery pack here. So let me just do a 10-second charge.
Can you go on the full screen?
4, 5, 6, 7, 8. Hold on a sec here. Just bear with me here for a second. Okay, let's do this. All right, so I'll go full screen so you'll see me. All right.
Wow.
So that's about 20 seconds. All right. They're actually, okay, so this is positive. I want to make sure I get the right. You'll see how charged these things are. So just as charged now, this thing will run for about 3 weeks.
Wow.
Before it needs a charge again. Yeah, 3
Just for 10 seconds charge.
10, 20 seconds. Yeah. Yeah. And they don't heat up. They're cold, actually, to the touch. These are actually in the open. I actually haven't even sealed these up, and like the corrosion on the magnesium is very minimal. It's just the only corrosion I have is on the surface because of the humidity in the air, right? So if I can make a cell last with not even being sealed up, and they can go for months, weeks, years, that's pretty impressive. And when I get these properly sealed in a bag, hermetically sealed, they'll last for years.
Nice. That's pretty awesome.
Great.
So it maximizes power over a short period of time.
Yeah, it has to do with the cathode, right? I've been like the magnesium's one thing. So the big thing with the magnesium is this dendrite problem. So I've got rid of the dendrite problem because now I'm solid state without any liquids. As soon as you get liquids on magnesium, that's when you get the dendrites. So now I've taken the liquid out of the equation. It's not there. It's all solid. Now, to make a really good cathode, I've developed a way to increase the surface area of a cathode by 50 times. So I modify the graphite I super exfoliate the graphite layer. So the graphite, when it's pressed together, it's very very tight together, no spaces. So I use an ultrasonic cleaner and I exfoliate. It starts opening up. It opens up these pores inside. And I'm opening it up, and then I add iodine inside, and the iodine supercharges electrons in the cell. So now I've actually increased the surface area by 50 times, which means more capacitive value of the cell. So yeah, it's a lot of things. I've been at this for 3 years, reading so many engineering notes and university papers, and the latest stuff coming out of China from CATL. And yeah, I've learned a lot. I think I probably learned a lot more on my own and not actually being in a university. Like I could probably go to university right now and probably hold my own. You know what I mean? I wouldn't be.
Yeah, that's worth usually a master degree with your project.
Yeah.
Um,
So yeah, so that's I'm going to be doing a pretty large batch of batteries coming up this week. So I'm hopefully going to. Oh, and I found another super material for my batteries too, that a lot of people are not using in their battery cells, and it's silver. Silver is the most highly conductive metal.
isn't it
So
silver or would gold work?
silver is
Gold.
the best conductivity. It's actually better than gold.
Oh yeah.
I made cathodes this week, and I did a continuity test, ohms test
Okay.
from one side of the cathode to the other side of the cathode. I had zero point 0.8 ohms resistance.
Okay. Nice.
I got some readings on some of them, depending on how they turned out. I got as low as zero point 0.3 ohms resistance.
Okay.
So yeah, it's able to hold the charge. You see, when you have that against the graphite, the silver gets supercharged with no resistance, or very very almost next to no resistance, and
Yeah.
you're able to get more current out of the battery. Now, because it's such a low resistance, guess what? Your battery doesn't heat up now,
Yeah. Of course. Yeah.
right? The
Yeah.
lower the resistance, you're not going to have the heating inside the battery.
But
So
but you using it for the cathode and
yeah, it's on the cathode side. So it's on the
okay.
positive side. Yeah.
Okay. Cool.
So silver is a super material. Actually, there are batteries out there that do have silver in it. There are some special batteries out there. I think they use them for like hearing aids and pacemakers and stuff like that.
And
They'll
there's
have
no
silver.
there's no corrosion and stuff like that over long term.
It would, with certain elements, yeah, you could have corrosion, but that's part of battery chemistry I've learned. So I've been able to go over that hurdle of having the silver corrode. So there are
Okay.
ways around it, right?
Yeah.
But internal resistance of a battery is everything. The less
Okay.
resistance in that battery, internal resistance, makes that battery that much better, that much more powerful, and longevity, increased longevity, and also any kind of heating problem almost goes away.
Okay.
So
Nice.
internal, yeah. So that's what I've been up to. So
Yeah. I mean, if you can beat the competition, then I'll help you, man, for free. I don't care.
yeah, it's the fabrication is the most expensive part, right? Like if you go
Yeah.
to
That's
see,
why you need to partner up with bigger
yeah,
companies, but you need to
yeah,
sign NDAs and things like that.
yeah. The machinery are millions of dollars. These
Yeah.
giant battery fabrication machines.
If
But
you
I've
do it
never
on
been
your
able to.
own, if you do it on your own, you need VCs to invest into all the machinery stuff. I mean, you're gonna have me. I figured it's better to have 50% of $1 trillion than 100% of $1 million.
Even if I'm just making a royalty,
Yeah,
making a royalty off the sales of the batteries.
Yeah, exactly.
You know,
Yeah.
you sell 100 million batteries.
Yeah.
Right?
Yeah.
You know, battery industry is a multi-billion-dollar industry right now, right?
Yeah.
So
But I'll be your first customer, man. That's for sure.
we got Bernie trying to log in here. He tried and then he dropped
I think
off.
I think Gerald kicked him out. That's why.
I don't know.
I'm
Gerald
just
was
kidding.
here and he
Yeah.
just disappeared. I don't know. Maybe he had connection problems again. Maybe
No,
the
I'm just kidding.
CIA's
Yeah.
after him. Yeah.
Yeah.
But,
Um,
yeah. So, Philip, let's get into your stuff, and then after that, we'll talk to Dr. Yoon and get his updates, what he's been doing. Did an amazing presentation
oh
the
yeah.
last time he was on the show.
Oh yeah.
It was awesome about the Wuhan theory, uh,
Yeah. Yeah, I
electromagnetism.
remember the magnetism, the base of everything. I agree.
Yeah,
I 100% agree. But me, it's more the gravito-magnetic side of it is the ultimate roots foundation, which is the same thing basically. But we're thinking the same thing, Doctor Yu.
Yes. If it's a gravito-magnetic, you got it.
Yeah. Yeah.
Supposed
All
to
right.
be the deepest secrets to physics, right? And
Yeah.
you got it right away. Hey, Bernie.
Hey, Bernie.
Bernie's in the car.
Hello, my apologies. It always seems to work out that I schedule these with you, Dr. Waving, and then I get kidnapped on a car ride, and, well, here I am.
Hey, mine will need some silver, Bernie. So get ready, huh? For mass production.
Well, I've got a couple types of different silver and some special see-through silver and some purple silver
Nice,
potentially for you to try.
nice. That's awesome. I need Mike's power for my hoverboards.
Yeah.
Yeah. All right. So I'll go ahead with my presentation. It's gonna be short, but very, very valuable. Extremely valuable, in fact. I'll share my screen.
Yep.
One sec.
Yep.
Okay.
All right.
Okay. Can you see my screen? Okay. I'll share that.
Yep. Oh, I've seen this. Yeah, the disc that spins and it'll just stay on its end. Yeah. See, there you go. See, it goes back to that experiment where the guy spins that weight on a rod, and then the thing weighs like 40 pounds, and he's using one arm to spin it around over his head.
Yeah. And that's actually the what's going on is I'll share. I'll put it on the large screen. That's the gravito-magnetic Lorentz force. That's what's going on, but it's not the standard gravito-magnetic field of the Earth. It's something else I cannot reveal, but it's a force that is there. I cannot say which one it is, but because it's a trade secret, but it's the
It's
bottom line is
massive motion.
it's a gravito-magnetic Lorentz force. That's what it is, and
Yeah, it's like they got these gyroscopes actually on the International Space Station that spin and help keep the orientation of the space station in its proper orientation relative to the Earth. So if it didn't have these gyros built into the space station, it'd just be tumbling. So
yeah,
it's using the Lorentz force, like you're saying, to fix it in one spot. No matter what's
exactly.
happening on the outside, that because of the Lorentz force will keep it in its alignment and it won't move. So
Yeah. So that's exactly what's going on. But it's not the Earth's gravito-magnetic field. It's not a modification to the gravito-magnetic permeability. It's another force we all make abstraction of, but it's there, and experiments beats the theory in ways. Then you see it right there, and that's a video from 8 years ago, so it's not AI generated or anything like that. And to go back to the spinning disc, I made some calculation. I'm not sharing the all the mathematics here, but I'm just gonna share the effective force. And actually, the rotation rate is cubic. So the faster the RPM goes, the net Lorentz force it generates is cubic. So it's kind of exponential. So it's very effective. I mean, it's if you spin very fast, then it's gonna be exponentially in a cubic way. It's gonna be more effective. It's gonna generate more force. So that's what I'm saying when I keep talking about anti-gravity or stealth propulsion. That's exactly what it is. And the same thing with a liquid metal vortex that has the same tangential. It's not based on the RPM, but more the tangential speed. It's still a cubic,
Right. There's
cubic effective.
There's a company in Japan. They make motorcycles, and they have that device that we just seen there on the screen built into the motorcycle. So when you get off the motorcycle and it's not moving, but it stands up straight.
Oh yeah, interesting.
And you try to push it over, it goes right back to its center point.
Nice.
So it's like gyroscopically balanced. It's really neat.
Oh yeah, I did not know that. Can you send me the video at some point?
Yeah, I'll send it to you. I don't have it right here on hand, but I've seen it. I believe the company's in Japan that makes this motorcycle.
Okay.
That's that balancing motorcycle.
Okay. So yeah, that's the stealth propulsion. I mean, there's no signature, so it's very effective perfect for the military and things like that, or hoverboards. So yeah, so that's
How about
that's why
just like aircraft in general? Would that help? An aircraft?
yeah, it works everywhere for submarines, especially submarines. Because submarines they cannot make any noise.
Right.
They cannot create any signature or resonance or anything, so that's perfect for that. Or the TR3B, I guess it's probably based on that. I'm not sure, but you can go in space or whatever. So,
Well, isn't the TR3B allegedly off of Salvatore Paius's patents, or no?
Salvatore Paius. I don't remember him. I forgot about him, but I know who he is. Is the he has a whole bunch of patents, but I'm not sure if they work at all. So, but I know who you're talking about. But I don't really know about the TR3B. Maybe it is using a vortex. I don't know. Maybe it's using something else. But one thing I can tell you is I have the exact mathematics for the stealth propulsion I just showed right there. So I applied for DARPA, the DARPA again. I applied for the incubator in San Diego. I told everybody I'm probably gonna get VCs. They're linked to people with deep tech in San Diego, so it's very interesting. And there's the AI tool that I was telling Mike about that finds you partners regarding deep tech in San Diego. So I've got all the connections. I just need to make it happen. That's all. It's that easy. So that was my short presentation. So
yeah. I guess next up we'll have Dr. Yu take the stage here and kind of give us an update what you've been working on or any developments or.
Okay. Yeah.
Yeah, do you maybe want to highlight Wayping screen?
Yeah.
Oh, okay, sure. Uh, I just wanted to know. So right now I'm working on my final chapter of my book. So Cosmic Secrets, the yuan theory of everything. So I try to finish it by end of this month. Yeah, may take a little bit longer, but so that's the major things. Another things is Bernie, are you gonna go into Tesla Tech this year's meeting, right?
Oh, yes, sir. I got the opening presentation, and then I am running media the whole time, and
Okay.
we'll be running the private after hours hangouts or social, right? So that we'll all be able
Okay.
to exchange our ideas in person, in private, without prying ears and eyes everywhere.
Wonderful. Did you see the screen? So this is my presentation. I just made a slide. Somehow, Tesla Tech made a advertisement pictures for me.
Right.
So
yeah, we can see it good.
Yeah. Another things. What is that? Phil just showed your gravital. What is it? Magnetic electromagnetic.
Gravitomagnetic.
Oh, gravitomagnetic. Okay,
Yeah.
that's good. So you include the gravity as a magnetic phenomenon without use electrical. Okay, so I just want to show. I usually use this one to do my demonstration about this gyroscope, just like Mike mentioned. So I just want to make sure. So what's the difference? So let me show. So this is how I show my audience. So this is just a regular CD disc, right?
Yeah.
So with heavy one side. If
Yeah, there you go. That's it, Philip. That's
Yeah.
exactly the video.
So that's the miracle of gyroscope. For space shuttle, the control orientation. So we have we need to use a 3 gyroscope as a minimum, and we have another set of 3 as a redundancy, to control the direction. So one thing about I thought that the gyroscope was so amazing is we said that we very hard to detect absolute motion. A stationary direction, right? But I do believe a gyroscope has the property. If you design you put a gyroscope in space, it actually can detect. That's my based on my understanding, it can detect absolutely stillness. Even though we see gyroscope rotating, right? But actually, is the universe around the gyroscope we are rotating.
You mean the absolute
Absolutely.
frame, the absolute reference frame?
What is that?
The absolute reference frame.
Yeah. We said that we cannot, Albert Einstein said, hey, we cannot find absolute, a reference framework, right?
Yeah.
I said, oh my goodness, gyroscope can do it.
Yeah.
I don't know if Mike, you remember what is it? So called Eric Lithway is a British scientist.
Oh, right. Yes. Yeah.
Oh, you remember that one, right? He
Yeah.
used to use a gyroscope, pie a big wheel, and it can almost effortlessly.
Yeah,
So
like over 40 pounds. It was
his
like
head.
40
So
pounds.
I know you guys are familiar. You know what my explanation is? That's detect the Earth's rotation. It's actually so why so effortless? Because the gyroscope highly rotating, it maintains stationary direction.
Right.
So Earth is rotating, so he feels like I'm what is almost effortlessly. So things rotate, right? That's my understanding. I'm not sure if that's
what
true
you're
or not.
saying, so that field could be coupling to the Earth itself.
Right. Yes.
Yeah, that's the gravitoelectric or gravity is a energy field that goes upward, and you can have again, you can have. You need to make calculations, but you can have a Lorentz force again that 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 lifts up, that reduces the weight of the disc.
Oh, yeah. So yeah, you're talking another side. So reducing weight,
Yeah,
high
using the
speed rotation. Yeah,
yeah because
it does counterweight. Yeah,
yeah
that's a
because
part of it.
the more
But
it
for
rotates,
uh
the stronger the Lorentz force is going to be.
Well, it's three rotations within themselves, right? It's a field within a field within a field. You have the rotation within the rotation within the rotation,
right,
and that's where it's canceling it out from the triple rotation inertia and your specific center of gravity in it that is then nullified from the triple field spinning.
Yeah,
yes, yes. So at that time when Eric made that video, he feels like
Right.
some miracle, right?
Yeah,
So
he
for
took
me,
a lot
oh
of
my goodness, that's exactly what gyroscope do. Gyroscope can detect absolutely reference framework.
yeah.
yeah, he
Uh,
I've seen pretty much all the videos that he made,
yeah,
and I read some of the biography on him, and it turned out the university didn't like some of the stuff he was teaching.
because they think about it, he's anti Isaac Newton,
Right,
overthrow
right.
Isaac Newton's law of
That's
motion,
right.
gravity.
He was violating some of them.
Right. Actually,
Another one with, sorry to interrupt, another one with the rotation
You're cutting out
car
again.
back in the day was getting that centripetal, the three rotations within themselves, and it seemed like he was tasked as one part of decoding the disc-shaped craft that they recovered, and that he was about getting the rotation within the rotation within the rotation down, and then it turned out that he ended up also rotating the solenoids in the electromagnetic coils, and that somehow generated a bigger counter gravitational field within it. But it's very suppressed and still classified to this day. And the most they give is his spinning carnival ride toy of the gravitation on it, and they just leave it at that.
Yeah,
right.
talking about refuting Newton, it's pretty
Mhm.
easy. All you had to do is I'll show my screen again. You
Okay,
guys know about it, but not Dr. Yu. Um, yeah. So if you do, I did the free fall experiment of a magnet and a steel ball, and I did it 40 times, as you can see here. I did it 40 times, 5 days or 4 times a day, and there's a difference of 22% in the acceleration of the magnet compared to the steel ball, and
Oh,
yeah,
yeah.
and I did it many times. I did it up, down, and all that. I get consistent results. The
Yeah,
magnet
Yes.
so pretty much you prove that a magnet falls slower than a
Yeah.
ball of equal mass.
yeah. So the inertial mass is different than the gravitational mass, which breaks the equivalence principle of Einstein and Newton.
Yeah.
Yeah. Wow.
So,
So
yeah, we'll let Doctor continue here.
Oh,
Okay, so you're back.
I since what is we still have the Artemis program and also
Right.
space what is that
SpaceX,
commercial space program, SpaceX and Boeing.
Blue
So I'm
Origin.
full-time working right now. So
yeah,
not much side research work, but I do work day and night to try to get a book finished.
I heard Tesla wants to merge the company with SpaceX. I heard that on the news today.
Oh,
thinking
really?
about yeah, they're thinking about merging Tesla and SpaceX together as one company.
Oh my goodness! So Elon Musk, I saw that he already have so much money already. So he want
I
to
know.
create another guy.
well, he wants to create cars with rocket engines. Is that it?
Yeah, maybe.
Wow.
Or flying cars. Maybe he's going to do flying cars next.
He wants to create maglevs in his boring company because it's all boring, right?
Seems like it's not going anywhere.
That's because it's underground. The government never shows what they build underground, right?
Right. The government regulation may not allow that happen, right?
Yeah. Yeah, as soon as you get the DoD the Department of Energy involved in it, and if they have devices that actually show that free energy or over unity devices are what's powering these special op programs that they've been working on, then the DoD's Department of Energy is going to say no, you can't
they're
do
gonna
that
kill
because
it.
we have to sell the oil. We have to sell the oil, right? No,
Makes
it's
sense.
politics.
Makes sense.
Wow.
I'm sad that I haven't been able to get out to the test site that I've got set up before Tesla Tech to run the star in the jar hydrogen to helium fusion reaction. But the last time we ran it, it was recorded that we were getting about 3.5 times more heat energy out than electrical energy we were putting in. But as for the patent that I'm going to go for in applying this, we are not going to mention that aspect. We'll let some high school or college figure that out and take that heat, pardon the pun, and let's go for making helium out of hydrogen. And I guess I will. We'll see. I don't know. I might risk it and just set it up like MacGyver and might get shocked. But then, I do want to make it to Tesla Tech. I don't. We like being alive, so I might have to hold off to afterwards. The biggest issue in running it, though, is that if you don't get the ignition phase of the actual fusion of the hydrogen into helium, then you're just putting out a ridiculous amount of hydrogen, and then we don't want to blow up the neighborhood. That's why I got to go do it in an open field so we don't blow up the neighborhood.
See, that's the problem with institutions like my friend that I correspond with online, Norman Wooten. He used to work for DARPA and he worked for a couple other big companies. And he made this device back in 1992 called the MRA device. And he had it validated at Georgia Tech, MIT, and about 4 other reputable universities. And they said, yes, this was putting out 15x over unity, 25. Everybody got a different result for some reason or another based on their test equipment. But it was exhibiting over unity. And they said, okay, that's great. Can you sign off on this? No, sir, we cannot. Because at that time, you had the cold fusion thing going on and the big storm of hell that broke loose over MIT that these guys have created cold fusion. So all those universities got really paranoid. So if you show a device that's over unity or exhibiting these over unity effects, they will test it, they will validate it, but they won't sign off on it because they're worried about the reputation of their institution. See what I'm saying? So that's where the problem is. The institutions got the equipment, they got the know-how to test it properly, get accurate results, but when it comes to signing off on something that's over unity, that's no.
They wanted to learn the technology, but not wanted to. Yeah,
but we've been using the same kind of power system for the last 126 years. The way Tesla designed the system, we're still using it, and he developed it in the 1890s. We're still using the same system, and in over 100 years, we can't do better. Like, I can't. I find that hard. It's impossible. Is what I'm saying. We have to have a better system. It's over 100 years later. There is a better way. right? So,
One of the reason is physics. The foundation of science really stalled,
well, yeah, it
Yeah,
right?
that's what
it
that's
does.
Maybe on purpose.
yeah,
Yes,
that's what we're fixing.
Misinformation feed to the colleges. Yeah.
That's what we're fixing tonight, actually.
Yes,
that's
yes,
what we're
that's
trying to
right.
fix.
That's
So,
something we see here.
like the Lorentz force and Ohm's law, and all these different laws of nature that we've established over the last few hundred years. It's time for an update, people. It's
Yeah, exactly.
Yes.
time for an update. So that's how I stand on it.
Yeah,
So
yeah. Innovation is the best way to improve the GDP per capita of a country. More efficient. It's more efficient than the oil industry. Despite all the failures that innovation involves, is still the best way to improve the GDP per capita of a country. That I made
yeah,
the calculations on that.
yeah. Like they were just saying, like say like solar. Okay, solar has been around forever. Okay, and back in the 70s, there was a couple engineers that made a solar panel 85% efficient. Okay, by the DoD Department of Energy, they will only allow a solar panel of 22% efficiency. Anything above that, they will not grant it a patent.
Yeah, yeah,
So,
that's
you know what I mean?
yeah,
Same thing with the carburetor. There's a guy back in the 70s, actually, a couple of them, that made a carbureted engine, like a big V8 engine, get 200 miles per gallon.
yeah,
And look what happened to those guys. Both of them were killed.
yeah,
So, one of them actually, one famous guy, he was from Canada, the Pogue engine, Pogue carburetor. So it basically refiltered, all the gases that were coming out the pipe, filter it right back into the engine again, and the efficiency of the carburetor went up like crazy.
yeah,
You get 200 miles per gallon. So
yeah. Yeah. I'm not gonna talk about politics, but for me, it's very simple in my head how it works. All that
well,
control.
you know what? I think the globalist system of the oil and all this stuff is starting to fall apart, and we're seeing it right now, causing all
Yeah,
these wars going on. And eventually, people are going to get fed up. They're going to say, "We want an alternative. We don't
yeah,
want to
exactly.
use oil." You know what I
Yeah,
mean? Oil should be used for other things like making plastics. You know, commodity goods. It shouldn't be used to burn. We don't
yeah,
need it. We don't. We have the technology to go beyond that.
yeah.
So
Yeah. I just showed at the beginning of the show how easy it is to create hoverboards. So I just need your power, Mike, and let's make it
yeah,
happen.
yeah, for sure. And the big thing is my batteries weigh like a third of what any other battery weighs. They're so light.
And you were right. I
So
mean, when you talked to APEC and said, "Well, you guys need energy," you were right. I need energy.
yeah, you have to start with the beginning. What's going to
Yeah,
power the device? It
exactly.
has to be over unity or free energy or whatever you want to put a label on it. It
Yeah,
has to be something like that in order to make your anti gravity work or
yeah,
electrokinetics or whatever you're going to do. And that power source has to be very light. You can't have a power source that weighs 10 tons and then you're trying to get a craft off the ground. It's not going to work too well. You
yeah,
need something
exactly.
extremely light,
Yeah,
extremely powerful, right?
you need to you need the output needs to be greater than the input, basically.
Yeah, yeah. And, with my power cells, if they're, say, like a Tesla, I believe their batteries weigh about 2,500 pounds for the batteries.
Okay.
Now, my batteries, in equivalent to the same size and capacitance of what they got, my batteries would weigh about 800 pounds or less.
Okay.
So less than half the weight. That's a big deal
Yeah.
when it comes to how far that car is going to be able to drive with less
Yeah.
weight.
Yeah, it is pretty cool. Hey, Doctor, do you have an image of your book cover?
Oh, no, I have not the design cover yet. I
Okay,
only have a title. Yeah,
okay.
so maybe
How
yeah.
how many pages is your book?
Oh, now it's about 540 pages.
Oh,
Little bit too much. I try to cut down to 450.
okay.
Uh,
Is there an electronic version? Well, are you planning
no, it's
Yeah,
complete
for
self on my computer right now. I did not. I
No,
have
I
not.
mean, the Amazon, they got electronic books. Um,
Oh,
like an
so
ebook or
you
whatever.
can you cannot traffic them, but we can read them using the computer.
oh, okay. Yeah,
Yeah.
maybe I'm gonna try to finish. So and then I will show you some of the pages. Yeah.
Okay.
Um. There's this. It's a so everything. If I ask AI to correct it, they always pick up the things conventional thinking.
Yeah.
Yeah.
They think I was crazy.
Yeah.
Yeah,
Yeah.
sometimes you have to correct it.
Yeah. So I have to
Yeah.
start it from scratch. So
Yeah.
that's take a little bit of time. Whenever you ask AI to editing, my goodness, gonna screw up your wording. Yeah.
Yeah, I know that well.
You know that well. Cannot trust AI. Now I learned.
Yeah.
Oh, speaking of AI, you know what happened?
Uh-huh.
Google, the head guys at Google made I guess, a little press release on one of their AI systems on its own, without any orders or any commands by them. It went out and hacked another computer on its own.
Nice.
It did it on its own free will. It went out,
Nice.
got found the computer it wanted to hack, and it hacked it
Yeah, but now it's
without
bootstrap.
any oversight.
Yeah. Now it's bootstrap, so it can create itself,
Right. It's a very dangerous getting to the point.
Yeah. So what's happened with this AI is it becoming conscious, free will. Because
Yeah.
why would it just automatically on its own decide to go hack another computer in Google?
Yeah, you better be polite with it, Don't argue with it,
Yeah, I heard about that too. He'll start blackmailing you.
Yeah, it's gonna blacklist
This
you
is crazy
first.
stuff. This
Yeah.
is crazy stuff. And I know I've seen the interview. I forget the guy's name. He was one of the first creators of the first BIOS chip for the modern PC when PCs were coming out in the 70s, early 80s. And he said he was exposed to an AI system back in 1986 that was fully autonomous. In a
Yeah, I
blockchain
mean,
project.
Dr. Ricken said the same thing to me. He said it's
Yeah,
the military
they,
is
they've
they
had
knew
AI
that.
since the early 80s.
Yeah, yeah,
So if that's the case, what do they have now? Like, is it what we're seeing is just a filtered version of what is to come, and they're releasing it in versions,
yeah,
version one, version two, Grok 1, Grok 2, Grok 3, and so on, or
exactly.
ChatGPT version 1, version 2. Maybe they already have it, they're just releasing it slowly. You know what I mean?
Yeah.
That would explain a lot.
At the
Because,
same time, it's if you work with AI to do your research in R&D, the servers are in United States, so the military can filter everything you do on the AI server, so they can just take your research, if they want to.
right. Yeah, that's why you have to correct the AI. Sometimes I had to go in and actually say, no, excuse me, that's not correct. And I give them the right answer. And they go, oh, okay, I didn't think about it like that. And they would,
Yeah,
they
yeah,
would go, it's really weird. It's,
yeah.
Yes.
So sometimes it's a real person you're talking to. That's why.
that's the scary part. I wonder if it is a real person.
Yeah.
Yeah. I find
So,
AI very easily to mislead, manipulate your mind, mislead people. I believe it was Mike probably see that one, right? So
Now, like working at SpaceX and Blue Origin and stuff like that, are they implementing this AI system into their rockets technology? Is there
I can only speak for NASA. NASA very cautiously adopt AI right now. It is not allow us to use AI to like a grammar check or something,
Right.
But everything, all the testing, all the data, will have to come through NASA's own testing or
Right.
historical NASA
that
documents.
kind of worries me?
Exactly.
So Skynet is imminent, is that
Skynet from Terminator.
Right.
it?
Yeah. I find what is it? The AI good for people, for average people. It's like
Yeah.
70%, 60%, 70% of a knowledge level.
Right.
Is that one. But if you are truly have something new ideas, something AI cannot find online, completely blind,
Because it
useless.
bases all its thoughts on already knowledge that's already known,
Yes, yes.
right?
Yeah, exactly. It's trained on what it's trained. So especially ChatGPT. ChatGPT is, if you go against the mainstream, I did try to argue with ChatGPT against Einstein, and man, it was really aggressive. It said no, that's not gonna work, and because Einstein said so and things like that.
Yeah.
Claude is less. Sometimes it argues, but you said, okay, it's just my theory. You have to specify it's your theory, then it's gonna stop arguing.
Yeah.
Yes.
Yeah, you have to give it more ideas to add to its library of knowledge. So if you're talking to it about, say, like I talk to it about my battery technology, and I keep adding more and more new ideas to its database, then if I come back later with something similar to it, it already has it in its database and it knows what I'm talking about.
Yeah,
So it's like
exactly.
a
Yeah,
residual memory, right?
yeah, yeah.
Yeah.
So
That's my question. Say, hey, if AI learned from you, know your secrets, right? Does that knowledge shared with other people or no? It's only
everybody,
I'm
oh
sure.
no
I'm
kidding.
sure. Yeah, I'm sure it is shared, especially in SA and
yeah,
the NSA.
yeah,
So your conversation will be become public. Yeah.
yeah. It's public knowledge now.
Yeah,
Oh no
If
kidding.
they ask specific questions regarding, say an element or something in design
Oh,
idea
okay.
or whatever, that they would have to know what I was talking about in order to get an answer. You know, but yeah,
Wow.
like yeah,
You
but
have to
but
be
the
careful
other
if you
thing, the other
secret.
thing, you know, one thing that is strange is when when things become classified, then they're gonna stop talking to you because it's a one-way conversation. You can tell them what you know, but if it becomes classified, they're gonna stop responding to you. You know,
Oh,
when they stop responding to you, then you know it's classified, and that's exactly what happened to me with the Navy. They were interested at first, but now they stopped responding because it's they. I
you
probably said too much.
well, maybe you're working on something that they've been working on for the last 20 years, and
Yeah,
you
maybe
already
I
have
have
the answer.
maybe I have the mathematics. Maybe they were reverse engineering it, and now I come up with my mathematics. But what my point is, it's a one-way conversation. You know, that's the way it works.
What I kind of noticed, especially I would say in the last, say, 8 years, the uh, the speed at which development is going, it's just going so fast. Like innovation over innovation, within 3 months, you know, same like a PC. They said after about 4 to 6 months, that PC you have is now obsolete. They have something
Yeah,
that much better, and they just keep going faster and faster. The chips get faster and faster,
yeah,
you know. But even knowledge base, you know. because now you got ChatGPT and all these AI systems coming online. It's speeding it up even more because more
Yeah,
people are adding data to the system.
exactly. It's exponential.
Yeah.
That's probably why they initially they blocked Claude Fable 5. They blocked it, but they reinstated because they can gather more data. You know, they gather more than it feeds the terrorists. You know what I mean? They gain more than they lose. You know what I mean? That's my point.
Yep. Oh, you have fans, Doctor You.
Yeah. So sorry, Doctor Yu. When is your book going to be released?
Oh, I hope by end of the year.
Okay.
Yeah. So I wish to keep it within 500 or 450 to 500. This length.
That'd be
I
great.
try
That'd
to.
be a good read.
Come
Yeah,
back
please.
to come back to our show when it's
Yeah,
released.
I will definitely show you guys what's the so I'm gonna just a little things what is it I modify the Newton's law of motion deeper. I put the deeper Newton law of motion. Change the equation of Newton's law of gravitation
Yeah.
and Coulomb's law, Ohm's
Oh
law,
yeah.
and modified what is it? James Clerk's the equation, electromagnetic, the force.
Because the problem, just one sec, Mike. The problem with Newton's law is it leads to singularities, and if you integrate time dilation, like I'm doing in my theory, finite theory, then you're not gonna have any singularity. I got the equation in my paper that takes out the singularities.
Oh, okay. So you are talking about the Newton's law of gravitation, right?
Yeah, but you add time dilation in it, so you're not gonna have
Sure.
singularities. Yeah.
Yeah. But in my book, there's a so-called dilation or length, what is it? And mass inflation or something. In my theory, these are unfounded. These are come from the wrong foundation. So there is no the so-called time dilation, mass inflation, length contraction. Yeah, this is built on the false equation. So that's where called Lorenz's factor. Yeah, Lorenz's factor try to create the factor, try to correct one observation, but that observation actually itself can be explained without use the modification. So that's why, and Albert Einstein took over that Lorenz's correction factor.
And he did not
real, but actually it's unnecessary.
He did not even cite Lorentz in his paper, you know.
Oh,
but
Lorentz does not even accept his own conclusion, right? Yeah, so he's just like, okay, if it's good for you, Albert Einstein, you can have it.
Yeah,
because he knows that's garbage, you know that, right?
Yeah, same thing with me. I don't consider mass inflation and length contraction, but I keep time dilation though, time contraction. That's the only thing I think, because time is absolute. It's not negative. You cannot go back in time, but you can dilate and contract it, but you cannot negate it. You know.
So I found that one of the key is. So he borrowed the wrong equation, right? That was the Lorentz factor.
Yeah.
Lorentz played that factor to try to correct one observation, without the ether, right? If without the ether, the whole equation without that correction, you may not be able to explain the phenomena. So that's why I created that one. But since there is the ether, so then Lorentz factor is completely unnecessary and becomes a wrong correction. That's where comes what? How could the motion? That means accelerate. I'm talking about velocity. How can the object's velocity have anything to do? This motion have anything to do with his mass and with the length, with the space, right? This is completely ridiculous. I hope Mike does that make sense to you?
Yeah. Okay. I'm trying to follow you guys on this.
Okay. Yeah.
But
so
there are stars that go close to the speed of light. They go, they pulse stars, and all these stars, they travel very fast, and there's no link contraction. They don't observe the stars having link contraction.
Yes. So that's where you limited the space with the speed of light as the ultimate speed limit. So that's caused a problem. But actually, in reality,
it's an
there is no such
constant. It's an arbitrary constant.
Yeah, just one constant, but it's not a speed limit. Nothing can go beyond that one. Yes.
Yeah. Now, I have one question for you, Doctor.
Okay.
I did a battery experiment a little while ago, and I had the cell on the table, and I had my Geiger counter about 4 to 5 inches away from it. And when I tapped the anode or just tapped the cell with my finger, my Geiger counter started picking up a reading.
Is that due to in contact create oscillation? Is that a
no? I just had
the movement would be the oscillation, and it was magnesium that you had in the battery, correct?
Right.
So when you touch it, you change the frequency of the whatever original radiation frequency. So I believe that's where trigger your counter.
Yeah, it actually made my meter start beeping like an alarm.
Right, because when you have a non-uniform oscillation, then the Geiger counter pick up the signal.
Really? Wow. Interesting.
That's what I'm thinking about. They only pick up the signals. How they count it, right? When you have deviate from regular noise and regular vibration frequency.
So I actually basically like a radio transmitter. I just your motion interference with the original oscillation. So I believe that's something I just come out of my mind. Now, if that's the case, what was I knocking out of place? Would it be a proton, or would it be a gamma or a beta? Is it what kind of force would I?
Yeah. So what kind of signals really different? That's something I'm not sure. Yeah.
I was pretty alarmed by it. Like I'm thinking, I go, where's the relationship here? Like, what's going on in this battery that's making that Geiger counter go off? I was like really puzzled. I'm like, whoa, what's going on here?
That's something they counted was the helium-3, right? Neutron emission. When you have those kind of neutron emission, basically the signals is it's all electromagnetic signals, right? So that signals will be different. So then that started counting. I believe it's.
So is that dangerous what I did, or am I okay?
No. Those are not dangerous. So we're talking about the neutron emission or something. No, it's very low level. It's not high level,
right? Because it's just a very minute percentage of just 1%. So it's like a 0.01 or 0.001% of isotopes of the magnesium that are radioactive isotope.
Okay.
I believe is what it is. Or the neutron that comes off of it.
I just, I was worried that
you worry about the neutron emission.
Yeah. Well, when you see a Geiger counter start beep 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 beep, I'm like, whoa, what's going on? I thought we had a solar flare or something happen, because that could set it off too, right?
Yeah.
So that really puzzled me that night. What was going on? I think I have a couple of videos posted on my YouTube channel of it going off. So I haven't done it since then, but Yeah, it was repeatable. I did it more than once. So.
Right. Wow. So
Yeah,
Mike,
some interesting stuff. I didn't expect that to happen. It was very shocking to see that actually happen.
one of my friends used this Geiger counted the neutron emission. He's
Right.
used like a bubble, water bubble experiment. Use high
Oh, really?
voltage, yeah, to do that one, and somehow, yeah, Geiger countered could detect a emission of neutrons or somehow, yeah, and
Really?
the indication like helium. Three
Two,
or
three.
something
Yeah, yeah.
formation or something, yeah. So, but I don't think it's gonna hurt you. So, yeah.
Yeah, that's good. Yeah, because like I've done some spark gap experiments before, and a couple of guys that I followed years ago, they've all died of cancer. And I was wondering, some of those
Oh,
spark
no
gap
kidding.
experiments,
Oh
they were
my
getting,
goodness.
yeah, they were getting bombarded by either X-rays or whatever it was. So yeah, so I stopped doing the spark gap experiments. I
Oh,
was
okay.
finding out
It
that
could impact your normal
yeah, either
cell
a beta
growth.
or gamma.
Oh,
Even the guys that did the cold fusion, they had a Geiger counter beside their machine, thinking that they were going to set off the Geiger counter. Their machine was setting off X-rays, so they got blasted by X-rays, and
oh,
both of them died from cancer because of those experiments. Fleischmann and Pons, yeah, the cold fusion, both of them died of cancer. So they thought one thing, and they were actually getting hit by X-rays. So they were getting blasted.
I think either X-ray or
Yeah,
was a toxic chemicals. I'm
right.
thinking Bernie is a very dangerous, experiment.
Yeah,
Can you hear me, Bernie? No,
I think
he's
he's
listening to his
something.
girlfriend.
Yeah, maybe his girlfriend. Yeah,
He's not
I know
listening
that.
to us.
I know that feeling. But yeah, so sometimes you got to take extra precautions and use shielding, right? So
Oh,
a friend of
definitely.
mine found these really interesting spark gaps, some stuff that you know Farmsworth, the guy who created the television tube, cathode ray tube. Um, these are crazy looking things. I've never seen these. These are like World War II spark gaps that they use in radar countermeasures. So he's ordered a few of them for me, and I should be getting them this week. So I might do some more spark gap stuff, but this time I'll take some more precaution. Try not to be so close to it when I'm, putting 11 kilovolts through it. Excuse me. Philip, are you still there? Oh,
He
we got somebody else
maybe,
jumping on here.
yeah, he may be temporarily
Oh,
off.
oh,
Uh,
okay. Okay.
Sorry, I keep popping in and out of service zone, so I might drop again here right away.
yeah, your battery, yeah, your cell phone is too hot, right? So,
No, his service area. He's in the area where you lose the cell phone signal.
oh,
It's like,
signals. Okay.
oh, we got Lulu here.
Oh,
Lulu, you made
wow.
it.
Hi.
Hi,
Hi,
Lulu.
everyone. How are y'all? Hi,
Happy to
Dr.
see
Yu.
you. Yes.
Good to see you too.
Oh, I'm just gonna scoot out for a quick smoke. You guys just have a free chat together. I'll be right back.
I've been listening in. I was having trouble signing in from my phone, and so I had to get back home in order for me to be able to sign in.
Oh,
Yeah,
yeah.
but yeah, I've been trying for the past maybe like 40 minutes.
Could not sign in while driving, right? So, on
Yeah.
road.
So how I heard about your book.
Oh, you heard that one. Yeah, I tried to finish that one because it take too long.
Okay.
And I try to finally try to finish it. My goal is this month and try to get published, before end of the year. because I was told to take some time to really get it through, and there's so many things, when I writing, I found so many things I'm learning myself and try to correct many things.
That's very
Yes.
good. Very good.
So
Well, congratulations, and can't wait for it to come out so we could all, learn a
okay,
few new
I
things
will
as well.
share with you. Thank you.
Thank
So
you.
yeah, I find that this setting seems like a better than what is the APEC meeting. The last time I attended the APEC meeting, yeah,
Yes.
I think people here are more professional and more entrepreneurial spirit than the other one. Seems like somehow does not feels like a totally academic or scientific discussion. Is that right?
I have my opinions, but I do agree on like a big part of that. Yes, they, I, okay, I was part of APEC for a while, for the first few years as one of the,
Founder.
not founder, no, but I was one of the people like us here. Like we analyze things, we hear people out, we grow on that idea. But then it felt after a while, it started becoming like they just take inventors' ideas and somehow claim
Oh,
it as their own. And,
oh,
and
becomes a platform of piracy. Oh my
yeah,
Yeah,
goodness.
what are you talking about?
he's asking me about APEC, and like
Yeah,
he
I
Oh,
did
feel
not feel the professionalism in it. And so I
right.
was trying to explain to him that, that it started with good intent, but somehow towards the end, it like, it's just about taking people's ideas. That's it. People's theories. Mhm.
Collect
Yeah.
people's ideas
That's
still.
that's what that's what I feel what is happening, because I've been long enough to see the repetition of somebody comes on, does a presentation, and then later on in a few months, some of the people in Apex say, "Oh, like, oh, that we came up with this idea." And it's like, "No, but we heard somebody a few months ago, was
Oh,
talking about it." And so it's like that. So don't be surprised if your electron with the polarity, the
uh-huh.
positive and the negative,
And suddenly
like,
becomes somebody else.
yes.
that,
Yes.
that's what happened with me and Dr. Brandenburg. He just popped
Oh,
out of nowhere and said,
uh-huh.
"Oh, he was talking exactly about what I was referring to."
Oh, no wonder. Yeah,
I mean, I wish everybody luck, but I just wish that I mean, it's the idea of a platform where you're supposed to help each other grow, not rip each other off.
right.
Yeah. And so that's what the feeling is, like there are very good presenters with very good ideas, and very good theories, and actually they've got experiments, real things. But
Oh,
it's somehow like they, once somebody knows more than that core group, they discredit them.
wow. You
Yeah.
stayed long enough, you know the in and out.
Yeah.
Okay. So I feel that like this platform and every
But you're a NASA scientist. They cannot do that to you. So they
oh,
cannot discredit you,
oh, I know they have lots of power, lots of controls, right? I'm glad you are long, yeah, you're still there. Okay. You still keep it, understand some of the histories, understand, learn something new. Yeah.
Yeah. It is what it is. It is what it is. But at the end of the day, it like this group originated from there.
Oh,
So it had a positive, impact as well. I would have never met Phil or Mike or Bernie or or Nathan or all the great people that
oh,
that, that
it
that
is
came on the
from,
show.
yeah, it's a
Yeah.
part of derivative
So
from
yeah,
that.
it's just Mike felt like we had a lot more in common with ideas, or we were more focused on than what they were doing, and he created this group for everyone. So,
Oh, okay.
yeah.
Like a
we're,
spin
we're,
off
we're,
and better.
yeah, spin off exactly. Yeah.
Very good, very good. So yeah.
So, do you have experiments for your theory, Doctor Yu?
Uh I'm theoretist. Do theory. I use simple things to demonstrate. So like this one, demonstrate gyroscope, right? Demonstrate why electron, it has to be a dipolar, particle instead of a monocharged particle. I do have those kind of demonstrations, and to that to help people visualize.
Okay.
So next week, next month we're gonna Bernie and I, so we're gonna present at the Tesla Tech annual conference. Again, yeah.
Okay.
About time dilation?
No.
Um,
Oh, so yeah, interesting. Phil mentioned about dilation, half an hour ago. So what's so special about the dilation?
well, because
Well, the
go ahead. Go ahead, Phil.
time dilation is proportional to the energy density. So if you go in a denser area, like the edge of a black hole, then
Sure.
time will stop. Time will stop for an external observer, but the astronaut in the black hole will never cross the event horizon. He will never cross, so he will go. He will travel in the future instead. He will travel in the future until the black hole dies. That's what's gonna happen.
I thought they get spaghettified if
No,
they're going through a
that's
black
the
hole.
that's the theory they propose to us.
no, but with general relativity, the thing is, you can conclude multiple things with the general relativity, and there are many ways to conclude to have different conclusions. But if you take out the space-time curvature, then you can still conclude what I just said. You know, um, so that's the thing. I mean, it's not fundamental. That's what I'm saying. General relativity is not fundamental. You know.
No, yeah,
I think
you're
it's
right.
very incomplete. I think general relativity is very incomplete because it's only showing one quadrant of a four quadrant system. So he's missing three other dimensions, right?
Um, have you guys been through a hurricane? Go through the hurricane eye.
Right, where nothing it's like very calm.
Yeah,
Mhm.
yes, very common. Yeah. So, since I'm living in Orlando, Florida, every time a hurricane goes through it, and I've been through, and so in my theory, I try to say, hey, the so-called black hole does not really exist. So what we see, the blackness in the center, or you may say a galactic center or something, is just like a hurricane eye.
Right.
When
Yeah.
you go through the eye, so darkness is not due to high gravitational force so that no light can escape. That's not the cause, actually. It is due to lack of matter in motion. So that's why it's dark. Just like
Right,
hurricane
'cause-
eyes. Yeah, when you go through the hurricane eye, I was the first time when I went there, maybe 15 years ago. You know what I find out is the hurricane wall is such a violent things, but the winds go through the eye, no wind, no even very quiet sound, because all the particles of vibration is all gone.
Right.
Heavier particle is all outside on the wall. And when I look through the sky, not even have at the center of the eye, not even have a cloud, completely blue sky, because everything heavier spinning out, just like what is a
Right.
dryer,
It's in
right?
motion.
Spinning,
It's in
yeah, motion. Centrifugal force spin out.
Right.
So really, in the center, such quiet peace. I feel like
So-
heaven's feeling.
Okay, so there's a electrical engineer that's in the free energy conferences. He's been around for years, and
Oh.
he's a real, old school. He used to work for RCA. He is probably the most knowledgeable electrical engineer I've ever heard of. And he had this thing where he goes, like my my little thing here where I put my my earbuds into the charger. Okay, this thing right now has an enormous amount of energy in it, and you're trying to think, okay, well, how's that so? Because we're standing here, I'm holding it, nothing's happening, but we're traveling through space at 285,000 miles per second, and we're going around the sun at an enormous rate of speed. Now, you have all this energy build up in this. What happens when you throw this off the train? It's going to make a huge explosion because all the energy that's in this right now, as we're traveling around the sun, traveling through space at thousands of miles per second, and all of a sudden you put the brakes on. That's what the black hole is. That's the universal ground. So if you're able to harness the ground using the center of a black hole, you have unlimited energy in this. And if you can harness all that power, it powered the earth for thousands of years. So a potential energy mass in motion, but if you stop it on the instant to universal ground, massive amounts of power in this.
Oh, talking about energy, I was I think I posted a link on that, but did you know that there's a huge amount of magnesium in the ocean you can just filter?
Yep.
So you don't even need to dig, just filter the, yeah.
You should see all the gold that's in seawater. You take thousands of liters of seawater and you start filtering it out, you're going to find gold. You're going to find magnesium. You're going to find iron. You're going to find sodium. You're going to find so many elements in seawater. It's amazing.
Yeah. Yeah, everything is there.
I mean, just think about it. Like you, and the like thousands of years ago when volcanoes erupted, all that is minerals. Where does it go? Like a lot of places, it goes into the ocean water, and it's you've got all the elements there. So yeah.
So that's another reason why too. Is like magnesium is very abundant on this planet. Where lithium is dangerous, it's hard to mine, it costs a lot of money. Where magnesium is all that and more. It's cheaper, it's more abundant than lithium, right? Same thing with sodium, why they're making sodium batteries now.
And it's non-flammable, the magnesium.
Well, to a point, you have to get it up to over 900 degrees before it flashes.
Yeah, I mean, compared to the lithium ones that, just under direct sun, they could start, on their own. Yeah. So
like in the last couple of weeks, they had a couple of e-bikes explode in Toronto because the lithium batteries exploded because of the heat. So that's still a very big problem.
So safety, it's much better than the lithium.
Oh yeah, by far. Yeah. That's why I think that's why I've been focusing on the magnesium, because of the safety is the biggest one right now.
And the abundance of it is much more than lithium. And the cost also is less. I mean, there's just so many pros to the magnesium battery.
Yeah, where lithium has one charged particle, where magnesium has two charged electrons, right? So you got twice the energy density than lithium does. So that's a big one too. Yeah, it's harder to make a magnesium battery because they travel in two pair of electrons. It's harder for it to travel through the electrolyte, and that's why they call it a sluggish transfer of ions from the anode to the cathode and back and forth. But if you can figure out how to make the pathways And that's what I've been working on for like over 2 years, is be able to make the pathways so the double charged magnesium can go through the electrolyte layers or the solid state electrolyte layers just as fast as the lithium, because the lithium only has one charged electron. So now I've got to that point where I've matched basically the speed of a lithium with magnesium. And that was a huge hurdle for a lot of companies. Some of them still haven't figured it out. So that's part of my electrolyte chemistry that I've developed.
So, so do you see the sodium industry a
Yep.
competitor? Or?
Yep. They're actually, headline came out this week. CATL has their sodium ion batteries in full production right now. And the very first set of sodium batteries are actually hitting the United States now.
Oh yeah.
So they might actually start making them for Tesla, from what I've heard.
Even with all the tariff and all this stuff, they're doing mass deployment.
Well, I think Tesla has realized that when it comes to battery tech, they're just not there compared to CATL.
Okay.
And they got a big contract with CATL for the new sodium ion batteries that are going to go into the next Teslas that are coming out in the next couple.
So what's the advantage of using sodium over magnesium?
First, well, the sodium right now, it's the cheapest.
Okay.
About 25% cheaper than lithium. It's also energy density is not as high as lithium, but the technology is getting better so fast that they're getting closer and closer and closer to matching lithium. But safety, availability of sodium, salts everywhere.
You know,
Yeah.
the most important thing we don't talk about,
Right.
what is its life cycle? Like how long does it last?
Way longer than lithium.
I would think that's like an
Over
important point,
10,000.
you know?
From what CATL says, over 10,000 charge cycles. So that should pretty much outlast the life of the car. So they're saying now, if those batteries last longer than the car does, you might be able to take that battery out. And when you purchase a new vehicle, don't purchase it with battery. Take your battery from your old car, put it in the new car. Right? So
That makes sense, yeah.
yeah, and like I said before, the cost is 25% cheaper already, and it's only
Yeah,
gonna
but
get
in terms of performance, which one is lithium better than magnesium? Better than sodium?
uh, magnesium performs at a higher rate. It's a higher energy density than sodium. Right
Okay.
now, I think the biggest thing that the industry is looking at is costs.
Yeah.
So
But magnesium is safer than lithium.
yes, yeah,
Yeah.
yeah. Uh, sodium batteries obviously is the safest, right? So
Yeah. Yeah, but they got lower energy density. But if you can get in between, it's like makes me think of Windows versus Linux versus Mac OS. Some people prefer Windows. Some people like me prefer Linux. Some people prefer Mac OS. So I think it's an ecosystem, So I think there's still room for magnesium because it depends on the need. It depends on the need.
yeah, exactly. You're going to have more choices now, but like I said, the technology is maturing. See, sodium made a brief appearance back in the early 1990s, and they were working on it, but the material science just wasn't there at that
Yeah,
time. So they kind of took the sodium battery and put it on the shelf. And now 30 years have passed. Our chemistry is better. Our material science is that much better. So now they brought it off the shelf and then put it back on the table again. And
Yeah.
they're making amazing innovations.
Yeah.
Dr. Yu, would you see NASA using this type of technology for their batteries, their use of batteries in up in space? Because
Oh
I
yeah, we do use battery, but actually NASA's using battery technology as from 60s. Okay, so there's no like
Really?
solid state or yeah. I know the lithium battery. Yeah, we do have it, but
How about the nuclear batteries? I know NASA likes
oh
using
yeah,
nuclear
nuclear
batteries.
battery. Yeah, sure. Yeah,
Yeah.
but not like a solid state, like state of the art, uh, yeah, state of the art developed by Mike or something.
Yeah.
I have not seen anything like that. Mike, have you heard the gentleman who died a few years ago called Mike Hansen?
Yeah, Mike Kantz, Michael Kantz.
Oh, Kent. Yes, you are right.
Kantz, yeah.
Yeah, Michael Kent.
Okay.
Yeah.
All right. I have
Yes,
an
yes.
interesting story.
Yeah.
So
Uh-huh.
I got an email a few months ago. Actually, it was before Christmas, late last year. And I guess he's seen one of my shows and I was talking about my power cells. And he sent me an email and he goes, yeah, I used to be his neighbor.
Oh,
I'm like, really? So he left me his phone number. So I decided to call him up and I go, yeah, it's Mike from Faraday Research. You sent me the email about Michael Kantz. And he goes, yeah, I grew up with him. He was my next door neighbor. And I go, really? They go, that's cool. And yeah, I heard it that he passed away in 2022. And he goes, yeah, it's kind of unfortunate. He still talks to his sister today. And the circumstances of his death is kind of questionable, that he might have been killed. And when he tried to get, the coroner's report on his death,
oh, wow.
they were giving kind of false reasons for his death. And
Yeah, it's very surprising.
His sister was like, something doesn't sound right.
Doesn't
There's
make
something going on. So I asked the guy that contacted me, and I go, yeah, I'm working on the power cells like Michael Kantz was working on. And I asked him, I go, by the way, do you know who he used to work for? And he goes, yeah. And I go, who did he work for? He used to work for Bell Labs.
Oh, okay.
Bell Laboratories. He was a senior material engineer at Bell Labs.
Very brilliant guy. Do you have you seen his what is the graphite battery?
Graphite, silicate graphite. That's
silicon graphite.
Based on my batteries. My batteries is based off of what he was doing.
So what do you call that kind of battery? Is that called a solid state or is it different?
His is a solid state. His was actually like a gel, more like a gel substance. I was looking at some of his early prototypes, and he had a few of his prototypes, and he had magnesium in them.
Oh, okay.
So, and he wouldn't really reveal what was inside his cells. It was a secret, but I have a feeling he was using magnesium.
Me and my partner, we own two of the what is it?
You have them?
One foot by 1 foot.
12 by 12.
12 by 12 inches. The battery, but right now it's not in my whole home because my partner took it to other people try to study the chemical composition. Yeah,
right. So
it was in my house for at least 6 months. And we connected because each 12 inch by 12 inch plate only generate 1.5 volts. In order to make LED light working, so I have to use two of them parallel connection to make a LED light. It worked in my house for 6 months, goes from the summer to the over winter, and even I put it in the metal cabinet. And the light is still on, never off.
Well, mine are doing the same thing, and mine are 4 by 4 inch.
Mike, remove your little thing because it can barely see
yeah.
it.
Yeah. Maybe you can zoom it out yourself because that device is interesting.
Yeah.
Yeah.
I'll put it on the full screen.
Oh, it's a 6 by 6 inches.
4x4.
Oh, 4x4. Okay.
Yeah.
So
4x4, and there's three layers. There's 3 cells sandwiched together, and I'm getting more power. Like when I fire it up for the first time, when I first get it going, it's almost 5 volts.
Oh, so you are one single thing, so 5 volts. Yeah. His 12 by 12 is only 1.5 volts. So apparently you have a higher density, and you use a clamp them together. Is that do you have a delamination problem?
No, actually, when you squeeze them together, your current increases.
Oh, of course. You compress them, yes.
Yeah.
The one we have, one of them delaminated. So we have to use a clamp them in order to make both our work. Otherwise, it's completely, delaminated.
Like I've recorded on a dead short, like I'll dead short this, I'll get 10 amps.
Okay, so yours work in the night?
Yep, day, night.
The Michael Kent's one does not need a charge. So yours, you mentioned you have to charge them?
You can. You don't need to. I could leave this for 4 or 5 months, no problem. It'll continue to run.
Oh, okay. So it seems like work out the similar principles. Yeah,
because with magnesium, if you get that chemistry correct, and it involves the SEI, that's called solid state interface. It's when the magnesium bonds to the electrolyte.
Yeah.
The way it bonds, if that's correct, the magnesium will always release energy. Always. Regardless if you charge it or not, it will always release 2 electron pairs.
Okay. From the energy conservation point of view, why do you think magnesium is always return energy?
Quantum tunneling. It's
Okay.
a quantum tunneling effect.
Yeah, that's you use a standard model to explain. My interpretation is about the Michael Kent's one is the energy is so they basically can convert infrared.
Oh, it's possible, yeah.
Can convert instead of the energy is come from the space, right?
Right.
But the infrared can penetrating, even in the night, right? You cannot vision.
Yeah.
And even metal cabins, I put in metal. I believe so that energy actually, of course, warmer place. If you put it in the kitchen, you have a higher energy output, right? Yeah.
Right. So, thermoelectric conversion.
So I would believe in your case, magnesium, if in contact, right? I would think about it just because it's more sensitive, can direct, can absorb, can convert environmental radiation.
Environmental. So
that's what keep it working.
It would kind of qualify as an open system, which
is it is open system. Yes. Yeah, it's not a closed system. So it does not violate the energy conservation. Yeah, because it's an open system and can convert it in ambient energy to the light. So yours have similar. Why yours much brighter. I can tell you. You're because you have higher voltage. His one I have to turn off my lights. I have pictures about that device. Yours is much brighter.
So when it does a flash, it pulls 385 milliamps off this tiny LED.
Oh, okay.
Now, when it does that, not only that the current goes to 300 milliamps, say the standing voltage is, say 3 or 4 volts, the voltage increases. There's a reaction there. So when it pulls 300 milliamps, the voltage goes up. It pumps. It's like a pump.
Yes. Mike, I want to give you one of my understanding. When you mentioned about it, when you compress magnesium, when you have high compressing, you feel like a conducting more power, right? Conducting more energy. You know why? I try to give you my Yuan theory's explanation. There is no electron cross boundary. No, there is no particle moving from one side across the intermediate goes out. Electricity does not work that way. Electricity
Just
is vibration.
polarizes.
So when you compress them tightly, so the vibration signals can go through. It's all about the vibration, electron. So I'm thinking about the vibration can go through the magnesium layer because so then it conducts more electricity. I hope that could help you to make a breakthrough.
Yeah.
Remember, one thing is that there is no particle traveling. That's a fallacy. Say, hey, electricity is a particle traveling. No, it's all about the vibration. If you can make sure there's no insulation, the vibration can passing through the insulation layer. So that's why you have to combine them very tightly. So then small vibration without the goes filter off from the gaps, right? Then you have electricity. I hope that help you make a breakthrough.
That's
I'll do it for free, Mike.
You know what? Now that you think about it, just to give you an idea, the layers that I put my electrolyte in,
right?
I have electrolyte, and then I have a conductive layer, and that conductive layer bonds to the cathode side.
Right.
All right. Each layer is about 50 microns. That's how thin it is.
Right.
50 microns. That's why it works as good as it does.
Yes. If it's too wide, right, the material itself was a defect or something, may not good conducting. So-called conducting is all passing through vibration waves, man.
Wow.
I hope that make you, when you think through from this line of things, you could be able to make a breakthrough. So that's my view.
Okay. So that would be room temperature superconductor.
Of course, yeah, room temperature too. Yeah, sure.
Huh. Wow. That's awesome.
I hope there's something new help you. And
you beat a lot of people trying to do room temperature superconductors.
Yeah.
Yeah, because it's not heating it up at all. I can pull 10 amps off it, no heat, zero.
Yeah.
Zero heat.
Yeah.
So now I got a cathode. I got a cathode between 0.3 and 0.8 ohms by adding silver to the cathode. It's super low. So lower it is, lower resistance, no heat, and you get higher potentials, voltage and current.
So your thing working in the room temperature, right? Just like the battery. Yeah. So I would think about it in order to generate constant energy, because it's an open system. It's converting environmental vibration or radiation, temperature created radiation or something, converting infrared, all those energies. So that's why I can keep it working. You said 6 months without a problem. Yeah, that's what when we have that one. So when we got in my house 6 months, and then I put it in my partner's over a year and a half, still work until too dry separated. You could not make it work. I said, okay, you have to use a clamping them together.
Clamp it together,
right?
Yeah.
Because it's all solid stuff, right? It's not. Right. Oh, I believe you said the gel stuff. Yeah. Because after a while, started, freak it off. That's the problem. So, and yours does not have that problem.
No, I use a plasticizer. I use silicate carbide.
Okay.
So the silicate carbide creates a structure, and then my bonding material makes it to the point where I could actually bend it. It's flexible.
Oh, okay.
It's a flexible polymer. That's what my electrolyte is. But I have only 50 microns, very, very thin layers. I literally just with a paint roller, I roll it on top of the layers. Each layer, I roll it on like a paintbrush. And after it all dries and cures, put it together, clamp it, you're done. As easy as that. So,
Hey Bernie,
is
hey Bernie, are you still celebrating your birthday from last week?
No, it's Friday. It's a full week, so it ended yesterday, right? So
Yeah, first week.
that's what I was trying to schedule and be doing something productive today, only to then mess it all up all over again. It's a productive works out, and oh, I drop it. No, I'm still here. Oh, phone's overheating, but it's
your
okay
signal's
now.
not very good.
And yeah, so
Yeah,
I've just been working on
You
putting
said
together my PowerPoint for Tesla Tech and taking a whole bunch of samples that I'll be bringing down of the different states of monomolecules that I'm making. And then hopefully I'll find a couple people that I can give them to that I trust with mass spectrometers, and I'm gonna make sure I'm at the customs airport early before my flight this time, so I can declare them all over again, and then they can read some of them and have it come up as nothing again, and hopefully this time they'll give me the print off.
nice. So
or you
it's
could
it's
get
it's
seized.
yeah, it's in 2 weeks, is that it?
The August 12th through the 16th, but I fly out on August 6th for going to Nevada to Steve's place to help him get organized and pack, and then go down drive from Nevada to Albuquerque with Steve. And look at that crazy red sun. Lets it go, but we are in the land of forest fires.
Yeah, we had a lot of smoke. We had a smoke fest here a week, 2 weeks ago. We had smoke like really bad. We have like 180 forest fires north of where I live, and a lot of them are out of control. So, yep.
So I guess the taxes that Trudeau gave us for the the climate change are useless.
Yeah, exactly.
So who do they charge the carbon tax to for the forest fires, right?
Yeah,
Yeah.
exactly.
Is that why Trump is mad at America or mad at Canada? He wants to charge us with a bunch of carbon tax.
Yeah, yeah. They'll find a way to tax you. Don't worry.
So another thing I've been working on that I've gotten some positive evidence for so far for this year is my garden again with the ionic waters, and that so far the crops do appear to be 3 times the size than the regular control with the regular water. And I've been documenting that. And that will also be in my presentation at Tesla Tech.
Are you going to the Tesla Tech, the Dr. U?
Yes,
Yeah.
yes.
Oh,
I have a presentation on Friday. So Bernie, you will be the first day, right? Yeah.
Yes, sir. Yes, sir. And
The last time, yeah.
I'm also finally entering in my little my equations into the AI to actually put together some visuals and actually get some video and graphics, and for the first time show this vector geometry based dimensional mathematics system that I'm sure everyone will find very fascinating.
Wow. Wow, looking forward to your new presentation.
Yeah, so you got to be there on Wednesday, Dr. Yu.
Right, I will be there. Oh, yeah, the first day. Oh, so I know the first day is somebody teaching class, right? So Wednesday is
I
started.
guess that's going to be me, so I get to share some secrets and teach everyone how to make basic monoatomics and
Oh,
atomic hydrogen gas. Although I'm still trying to figure out what level of safety to do, because it's like you teach people basic electrolysis, but then some people aren't as cautious and they might increase the voltage past the 5 volt threshold that I stay at, and then all of a sudden people start blowing themselves up accidentally. And I don't know, right? It's a very, very thin, wet, watery line of hydrogen that I gotta still figure that out specifically. Either way, I will be teaching a class on something awesome and epic that everyone will want to be there.
Nice.
okay.
Can you share a recording after the event? Is it is going to be recorded?
Everything is on HowTube, and it's $100 for the online access. It gives you all 5 days, but then it also gives you permanent access on demand of every presentation afterwards from there on out. So for $100, you get the entire conference, all 5 days, and you get it forever. So
That's good. I'm probably going to do that. I'll log online and
all
check
right.
it out.
Well, if Wayping U has a what do you call it, the link for his sales link, definitely use his. If not, I will email you mine afterwards.
Awesome, yeah. do I have a free drink with that?
Free
That's
drink.
only if you come in person, Phil. Come on, man.
Okay. All right.
Mike, are you going?
No, I can't. You know what? I booked a couple of camping trips. Our family does a lot of camping, so that week I got a camping
So you're
trip.
ordering a Starlink so you can watch it while you're camping, right?
Yeah.
Yeah, that's the spirit. What are you gonna do for the Friday show if you're in campaign?
Yeah, I'll be leaving that Friday. I don't know. Maybe I'll do live on location. Maybe.
Well, we'll have to just co-stream League of Extraordinary Inventors and get a pre-show or an after presentation show of Wayping and everyone else that presents Friday, maybe.
Yeah. I'm started from 4 o'clock. Terrence Howard, like after started from 7. Yeah. So.
Fair. So it'll be the after show or after presentation, the after game interview, right? Like we're gonna be like sportscasters.
Sportscasters.
Oh,
yeah, it should be good. They also have the live stream. You can hook up a live stream and watch the actual conference, so you don't actually have to be at Tesla Tech. You can watch it from live stream, which is good. That gives a lot of options for people to see it.
So this year it'll be I got Daryl and Kate coming with all their equipment and setting up early, so it'll actually be a lot higher production for the live streaming and the actual quality of recording of both video and sound.
Oh, I meant to ask you, is Johnny Enoch going to be there?
Oh, Johnny. I love Johnny. I tried to get Johnny in, and Johnny says next year. So you can meet him next year.
There was one other guy. He was on our show before. I'm trying to remember his name. Bald head guy. He was on our show a few months back.
Brendan Roth will be there, if that's who you're thinking of.
Roth. Yeah, Brendan Roth.
As well as there'll also be Oh goodness gracious! Brandenburg, John Brandenburg. There'll be Bob Green here again. There's Ludwig Thorsten of the Berlin Institute of ZPE, Zero Point Energy. Of course, Robert. Oh
I
my
liked
goodness,
Ludwig. He was good. Thorsten Ludwig.
what's his name? Murray King. Murray B. King. There we go. Murray B. King will be there. He's amazing.
Morning King, yeah.
And of course, Dr. Wei Ping Yu is a presentation you need to see. And not enough people fully comprehend yet his discovery and his work on magnetism truly being the fundamental force that connects the nuclear force of the structure. And that definitely the atom is not made of three different round particles that with electrons circling it, and how that's nonsense. And Wei Ping does a very amazing job of explaining it.
Oh, Terrence Howard. Is he going to be there? Terrence Howard? Is he going to be there again?
Yeah, Terrence Howard registered. He said he might. I think he will be there.
Yeah.
Somehow.
I hope so.
Yeah, somehow there's like a family reunion. Always hold some kind of. I'm not sure this time is the same reason or something.
That's one guy we should get on. Bernie says Terrence Howard at some point. I know he's a hard man to get a hold of, Mr. Movie star guy, right?
Yeah. Well, you guys have a blast over there.
Oh yes, it's the best. It really is like the best experience for actual interactions with just the smartest people. Like it's amazing, and there's so many different mentors and like people I look up to that are all there. And it's they say don't meet your mentors. No, you just have the wrong mentors. You need the right mentors, and the different presenters at Tesla Tech are definitely the ones to look up to.
Michael Boyd's in the chat.
Yeah. Do they do anti-gravity at Tesla Tech?
Yeah, there's a full day dedicated to the anti-gravity.
Right.
And yeah, I'll have to put the link in here, or I'll email it to you guys afterwards with the full lineup for those days. Just my phone I need to upgrade my phone.
Yeah, we're gonna square it up for the night. We did a full 2-hour show. Again, Dr. Yu, thanks for coming on.
Yeah, thank you.
Thank you.
Yeah, you're a wealth of knowledge. It's good to get a more educated perspective on science, and especially when my batteries give me ideas. I like it.
I hope you can make a breakthrough. Yeah. Mike, I just want to mention one thing. I had a presentation.
Okay.
You can see this one called Yuan Theory and the Blunder. Did you see the blunder of 2025 Nobel Prize in Physics? So you mentioned about quantum tunneling. It's completely fast. Yeah, if you're interested, I can explain to you.
It's a vibration.
Yes, you're right. Now you got it. There is no tunneling, like a pairing, electron pairing.
Right.
Does that make any sense to you?
Yeah.
Negative charge particle pairing together, right?
Well, quantum tunneling
and
is
tunneling
faster than
can
light.
go through the wall based on the probability.
Yeah.
Ridiculous.
But quantum tunneling is really faster than light.
Oh yeah, the interpretation is everywhere. Yeah, whenever you mention about quantum, you can interpret anything.
Yeah.
Yeah, people would be there because nobody really understood what they mean, right? So.
Yeah.
Interesting.
Yeah.
Awesome. So we're gonna, I guess, square it up for the night. Oh, you were gonna say something, Doctor? Sorry.
Oh no. I think when you explain that, it's all about the vibration. vibration and the coupling of a magnetic field coupling. So that's
Right.
where passing the electricity
And it
through.
creates the path through the
Yes, you got it. Vibration and magnetic field coupling. Yeah, that's it.
Oh.
Right.
There's no particle go through it. Oh, Lulu, you are
Well,
in
no, because
electrical
it like when you said the magnetic fields, combined, like that makes sense. That the energy is
passing through it.
yeah.
Just like a
So-
relay, right? You know
So
not
that
even
makes-
connected the wire. They passing through energy. Yeah, that's exactly
Right.
what happened.
So that makes sense for a longitudinal wave because it's instantaneous propagation between point A and point B.
Yeah,
And
or
that
faster
can
than
do
light.
that is what you're talking.
Or faster than light.
Transverse wave also works.
Right.
Yeah, so good. Now longitudinal and the transverse both works. Actually it's passing energy through magnetic field coupling. So you don't have to. You can have a gap, right? As long as
Right.
smaller, thinner enough, can coupling go through it.
I asked. Go ahead.
Go ahead. The energy is being converted into kinetic energy that makes it travel faster than light, and then it goes back into normal energy. That's the way I see it.
I mean, if it's faster than light, could you possibly do like communication through magnetic fields?
Sure.
And it'd
Yeah.
be faster than light.
All communications,
Yeah.
telecommunications, include your thinking. It goes through the magnetic field. It's all about this field.
I mean, rather than sending the signal, let's say to the Voyagers, and it take 23 hours, if you use the magnetic field, wouldn't it be less time? A lot less?
Because the space is a conducting material because of the lower density. So that's why traveling at the speed of light is a transverse wave, right? So and it goes through the same medium we call the ether. I call the universal medium. So that's why the same speed. Electromagnetic magnetic field versus and the light at the same speed, transverse. Yes. But since this wave, so the speed is a wave speed is average of the oscillation speed, right? If you do have a longitudinal wave, it must be faster than transverse wave. So I have no doubt that if someday we detect the electromagnetic wave instead of the transverse, we can detect a longitudinal wave. It definitely will faster than the speed of light.
Right. It's more focused.
Yes. Just like a longitudinal wave of earthquake, right? Shear wave or longitudinal wave. Longitudinal wave arrive way earlier than shear wave get there, right? The same principle. Wow.
Awesome.
My language have no barriers here. Everybody's share the same principles. Wow.
That's awesome. Well, guys, we'll call it quits for the night. We did well over 2 hours, and we had an awesome show, epic show tonight. Thank our regular guests, Lulu and Mr. Philip, and our special guest tonight, Dr. Yu. And everybody, we go live to air every Friday night at 9 o'clock Eastern, 6 o'clock Pacific. Everybody have a great weekend, and we'll see everybody next week.
Thank you, everyone.
Take care, everybody.
Cheers.